Hey everyone, in this video we're going to be learning about the for loop. A for loop is part of a programming concept called repetition. It refers to being able to repeat a set of instructions multiple times without actually writing the code that many times. If you think about it, the draw loop in P5 is something like that, because somewhere else P5 is actually calling the draw loop multiple times and that code is being repeated. Just like that, we're going to learn how to write our own set of instructions that are being called again and again. So to do this, first let's just draw a single ellipse on the top left of the canvas. So I'm drawing an ellipse at 25 with a size of 50. Okay, perfect. Now let's draw an ellipse to the right of this. So I'm just going to change the x value. Okay. Now let's draw another ellipse to the right of this. So that will be 125. So if you'll see, we can go on like this and we can actually draw 8 ellipses that we can see on the screen up until the one in the right over here. So what we can do is, instead of writing 8 separate lines of code, we'll write a for loop that runs 8 times. And within that we can draw the ellipse. So let's see how to do that. So I'm going to say for, that's how we start off with the for loop, and inside that we have to give 3 values. The first refers to a starting value. So I'm going to say I equals 0. For this we just have to also quickly go ahead and define I. Okay. So I equals 0. Then we have to give a condition till which this loop will run. So since I wanted to run 8 times, I'm going to say I less than 8. And the third thing that we have to give the for loop is the variable that changes and how much does it change by. So I'm going to say I equals I plus 1. And whatever we write inside these curly braces is what will repeat. So let's have a look at this. We're starting at I equals 0. And we're saying I less than 8 and I keeps increasing by 1 each time. What that means is the first time we enter this loop, the value of I equals 0, and because I less than 8 is true, it will go in and run it. And at the end of the loop, it will increase the value of I by 1. So now I equals 1. Because 1 is also less than 8, it's true, it will continue, then I will become 2. So it will keep on going like this. Now let's look at the last loop. When I becomes 7, 7 less than 8 is still true. So it will run what's in the loop. And at the end of the loop, when we say I equals I plus 1, the new value of I will become 8. And because 8 is not less than 8, it's equal to, it's not less than, the condition will not be satisfied and it will exit the loop and continue running whatever is below it. Okay, so now we know this runs 8 times. So I'm just going to delete all these ellipses code and put this one in here. However, we only see one ellipse right now. That's because we haven't changed the x value. The x value of all the ellipses are the same. So we're going to define the variable x and we're going to give it a starting value of x equals 25 and change this x value here. So right now it should still be the same. And then what we're going to do is we're going to put x equals x plus 50 inside the for loop. So what happens is when it enters the for loop, it starts with value x equals 0 and I equals 0. And then as it's running within the for loop, the value of I keeps increasing from 0, 1, 2. And along with that, the value of x also increases. Over here on the screen, you can see what the value of I and the corresponding value of x is. So now when we press play, we have all these ellipses drawn. X goes all the way up until 375. And after that, I stops satisfying the value for the for loop to run. So it exits the loop, goes back to the beginning of draw, draws the background, x gets reinitialized to 25 and this loop runs again. And this keeps running again and again. Now the other way of writing this code is, we know that the value of x is increasing by 50 each time. And we know that we want that to happen only as long as x is less than 400. Because the minute it crosses 400, we can't see it. So it's of no use to us. So another way of writing this for loop without using 2 variables, one as a counter and one for the x, is we can put this x itself in the for loop. So we can say for x equals 25, that's the starting value, while x is less than 400, that is the condition until which the for loop will run, x equals x plus 50. And this is the value that needs to be incrementing in the for loop. We can actually remove all of this over here. We can also remove this. And this gives us the same result as well. So practice using for loops a bit, because we need to be careful when we're using it that we understand what the three values we need to give are. Once again, to go over it, we need to give a starting value, a condition till when the for loop should run, and how does the value keep changing within. For example, if we don't give this value, right, if we don't say x equals x plus 50, what will happen is, since x is 25 and its value never changes, it will always be less than 400. This line will keep running forever, and the code will get stuck in what is known as an infinite loop. And it breaks our browser in the way you're seeing it right now. So we just need to be careful when we're writing for loops to make sure that we give all the three required values. So now that we know the basics of the for loop, how can we turn this into generative art? So let's use the random function so that the size of the ellipse actually keeps changing each time in the draw loop. So to do this, let's create a variable called size, and we can initialize size to 20 to start with. And then within the for loop, what we can do is, before we draw the ellipse, we can say size equals random from 10 to 40. This will give us a random number from 10 to 40, and we can give that as the width and the height of the ellipse instead of giving 50. So there, we already have these patterns coming at us, and they're like, and they're new each time. But the problem is that this is changing too fast. So how do we reduce this? Now, as we've learned, everything in the draw loop runs forever. Right now, it's running at a speed of 60 times per second. If we reduce that to maybe 5 times per second, we can see what we're working on. And P5 actually provides a function for this called frame rate. So this 60 times per second is actually known as the frame rate. How many times do you see a frame per second? Since the default is 60, we can go ahead and reduce it to 5 by saying frame rate and giving the number we want in here. When we press play, you'll notice that this is changing at a much slower pace, and we can actually see what's happening. Now let's add one more step of randomness into this. Let's try changing the shape randomly. So to do that, I'm just going to create a variable called shape and initialize it to 0. And within the draw function, inside the for loop where we actually draw the shape, I'm going to say shape equals random from 0 to 1. Now if you remember how the random function works, it gives us decimal numbers as well. So the shape variable could right now have any value such as 0.1, 0.2, 0.375, 0.92. So what we can say is, let this shape variable contain a random value. If that value is less than 0.5, then I want to draw an ellipse. Else, I want to draw a rectangle in the same place instead of the ellipse. So you can just change this to rectangle. Now you'll notice the rectangle is actually a bit offset. That's because the x and the y value given for the rectangle is the top left corner and not the center. We can either go ahead and change these, or P5 also offers us a function called rectmode, and we can give this as center. What this function essentially does is it tells the program, if you ever encounter the function rectangle later, the x and the y values for it are actually the x and the y for the center and not the top left. So that's what this function does. So when we press play now, there, we have the rectangles placed correctly, and we have a generative pattern where the size and the shape are randomly decided. So go ahead and add a bit more randomness to this. Maybe you can add a couple more shapes and also try and change the colors based on another number. So play around with this, and in the next video we're going to look at how to make this a complete grid and not just one single row. Thank you.